right. Good morning, everyone. This is the last episode of our 30 days, and today is a little bit special. We are doing a special session relevant to the next team. This is my research team, and today several folks are doing their final exams, but we will have a couple of discussions. Before I go ahead and get started with everyone, I'm going to give it just like a minute, and we're going to go ahead and get started. All right, I got the notification that the system is functional everywhere, and this is awesome for our last session. So today is a very special session for several reasons. The first one is this has been nothing short of an exciting journey for 30 days. The amount of messages, the amount of communication, the amount of emails that we've been receiving is nothing short of impressive. And what I wanted to do today is to introduce you to my team in a special way. So we're going to be having folks coming in. This is Clint. So I'm going to be showing the different people from the team. This is Rudy. This is Kaishu. This is Chris. This is Joshua. And this is Alex. As you all know that Alex has been a cornerstone in helping me to develop this full month. So we're gonna be talking about the different research that we do. We're gonna be talking with some of the folks, and we're gonna be doing some slides and different elements. And this is a little bit like the finale, and where we are going to talk about all of this together. So this is the picture of my team. This is a team that works on two aspects. These two aspects are I work on future factories and composites, and in the upcoming couple of so as we said, when all of this is over, we are going to move to a weekly format, and we're going to have more fun. I mean, we're not going to stop. And thank you so much for the tons of messages that I am getting from you folks. Hello to everyone. So let's go ahead and get started with this is a couple of pictures from the team. This is the composites team. So these are the folks that work on the composite section. So when you see in the next team, so my research team, when you see the future factories, composites manufacturing. So basically, we do have a couple of folks working in different sectors. So for example, like Alex, you will see him in Bose and so on. This is the composites manufacturing team. These are all students at the University of South Carolina and some industrial partners that like we work very closely with. Like for example, you can see from Torre, you can see from Siemens and so on. And a lot of them are graduate or undergraduate students. And you can see in here, Rudy Wehbe, he just graduated and got his PhD. Rudy actually will be, we will be talking to him in a couple of seconds as well. So this is for the composites. This is the future factories. So in the future factory, we're working on, and we will show you a couple of images. We're working on setting up a new standard when it comes to how manufacturing facilities should be like in the future. We have a excellent team. You can see them on the screen: Kaishu, Chris, Alex, Clint. These are the graduate students on the team, but also there's plenty of undergraduate students and so on. So this is something that we will be talking about as well. This is one of the other aspects of the research team. So this is just for fun. This is how our life is right now with Zoom meetings and just like everyone else in the world. And this is just a small picture just for fun. All right. So we do have a large number of the students, the undergraduate students, and we are going to I'm going to present them through a couple of slides and talk a little bit about what they do. Andrew Anderson is one of the most senior undergraduate researcher within the neXt team, and he has been nothing short of impressive in. So actually, I should stop saying that because everyone in my team is handpicked. They are all impressive people that I'm surrounded with. And Andrew is one of those few people that actually have worked on so many different projects as well. He has been to Langley, he has been to NIAR, he works with on McNair on several of our projects. And recently he just got a SC NASA space grant, which is like pretty impressive. This is a picture of Andrew. He is one of the AFP operators that we have at McNair, and this is just in time, just in sequence. This is Alex just threw this on the slide. This is how impressive he is. So this is awesome. So now this is Cameron. Cameron joined almost a year ago. He's a sophomore. It is that my research team is mounted in a way where there is a structure. I have a lot of undergraduate students, graduate students, and so on. But also, what's more important is we also open up the possibility for students in high schools. Actually, this summer, we were supposed to have 3 high school students full time within the research team. And this is something that, like, we take super pride that we integrate undergraduate students. We believe in the whole life cycle, or high school students. We've had that experience before, and I'm going to talk about it in few seconds. All right. So this is Cameron. He does with ASME, with SAE, and he's working on the digital twin for the AFP process. So this is Mr. Sacco. Let's add him. How are you doing, Chris?
I'm doing all right.
All right, awesome. So Chris is he had a, you know what? Why don't you introduce yourself? So for me, you're a big success story because not only what you've achieved, but also like you come from a little college, and then you just came and visit us at McNair, and then suddenly you finished your master's, now you're doing your PhD, and the world is yours. Tell us a little bit. Introduce yourself, Chris.
Yeah, I'm Chris Sacco. I have always been born and raised in South Carolina. I was born in Rock Hill. I wasn't really sure how everything was going to play out when I went and did my undergrad, and so I went to a very small liberal arts college by the name of Presbyterian College and kind of fell in love with the whole physics and math routine. And so I got my undergraduate degrees in physics and applied math, and really realized that research was kind of my passion. That's what I enjoyed doing. And so I shopped around a couple of different places and kind of found a home in McNair, and it was a great fit. And it's exactly what I love doing.
And I don't hide. I should stop saying that because I'm going to say it to everyone. I love our team. I think like if anything, if I attribute my like professional success, is really it comes from you guys. I mean, your work, your ethics, the team spirit that we have is just impressive, and I love it all from when we bake weird stuff and we share them with each other, to when we talk about stories that we should not even mention right now relevant to cats and whatnot, all the way to the amazing research that we do. So Chris, tell me a little bit about your research. What is it that you're working on?
Yeah, so it covers a couple of different areas. It's a little bit all over the place, but if you can think about it in terms of how it's structured, it's um, manufacturing, but manufacturing in a way that we can use inspection and inspection data to come back and influence our manufacturing process. So the big area that I focused on for my master's is coming up with interesting ways of doing defect identification in the AFP process. So we're doing the manufacturing of large-scale composite structures for aerospace, and we want to be able to look at defects, the potential for those defects to affect your structures. We want to do precise characterization of those defects. And then along the way, kind of what we discovered was that you can use a lot of that data to come back and influence your manufacturing process. And so we're in the process right now with finalizing a couple of investigations to go into how do your process parameters and how do your design parameters affect defect production. And so we're doing this in a very data-driven way. And so we've got a couple of things going on with that. And the other thing that we're able to do too is we're able to come back and we're able to update physical models, and so we can do more accurate predictions of, if you have a certain set of processing parameters, if you have a certain design set, how does that affect your defect production? How does that affect your overall part quality? Things like that. A lot of what I do is in the field of machine learning as well, and so we do a lot of computational acceleration. I'm working on a project right now where we're actually taking some information from structures and finite element solvers, and we are accelerating the process of doing that using some machine learning code and some machine learning algorithms. And then there's a little bit on the hardware side that I do. So I do a little bit of embedded programming, hardware acceleration, and then the other thing that we're working on right now is I'm actually working with Drew to help develop some pretty novel ways of instrumenting AFP machines, and in particular, getting temperature readings directly from your material during the AFP process.
This is nothing short of impressive. And I want to say a story about you, Chris. So Chris is someone that like comes to me, and like I'm sitting in my office, and then Chris barges, and I know, like, all right, he has a new idea, and he's gonna come and to tell me the following sentence: this is what I want to do, but don't worry, I'll do it over at night and in the weekend, so it will not take time from. So Chris comes every couple of days with a new idea, and I feel like my role with him is, no, you're not allowed to do that, just because I feel like I need to protect him from his time, because he's one of those people that if he had 48 hours per day, he would know how to fill them very, very productively. Chris, this is awesome. I love having you on the team. Tell us a little bit about this picture. So what was going on in there? Were you visiting Langley? What's going on?
Yeah, so we actually went down to Langley. We finalized a couple of projects that were involved with NASA, and so we got to go to Langley and we got to interact with people at NASA and a bunch of industry people and kind of display our work. I think we were actually the only group of students that were presenting there, and we're actually showing everything off that we had done. And so
we nailed it. So,
yeah, we went there. We got good reception on everything, but it was really cool. This is actually at Langley. I believe we were back in. It's actual like hardware space back there, and so they had a bunch of stuff that was intended to go on space missions, and so they had everything from robots that would assemble space structures in orbit to this thing, which I think was
it's an inflatable structure.
Yeah, expansion onto some sort of habitable space.
Yep.
Supposed to go on the moon or Mars. It was cool stuff.
I want to use this to also give a shout out to Benjamin Greenberg. Benjamin used to be a graduate student in our team and now has graduated. Benjamin is one of the most free-spirited people you'll ever know. He's just a inventor, and he wants to. I believe that someday he's gonna have billions of dollars, and I always told him from day one, like, once you get to this point, give us back to our research team and make sure that we're still striving. Chris, thank you so much, and stay tuned for. I might call on you in a couple of minutes. I don't know. Like it's just gonna continue impromptu like this. All right, let's get Clint on the air. How are you doing, Mr. Saidy? Oh, you're on mute. You've muted yourself, so you have to unmute your microphone. I still can't hear you. For some reason, I can't hear you. So this is how I'm gonna do it. I'm gonna go ahead and skip you, then come back to you once you have figured out your if there's something with your microphone. Okay, perhaps now I can hear you. Would you want to?
Can you hear me now?
Yeah, it works perfect. All right,
Hi.
Clint. So I see we have a nice chart, and I see you have the latest addition to your family. Tell us a little bit what you do. Research. Go ahead, present yourself.
So mainly I'm working on robotic health monitoring in the Future Factories lab. And what we're really trying to do is to try to collect as many as good data out of the cell and try to get the health of the robots in order to intervene whenever maintenance is needed, or in any other cases, if there is any foreign object in the cell near the robot that is not supposed to be there, also to be able to detect it, or also to be able to collect data regarding the product that is processed by the robot in order to help the process of manufacturing the product, especially if any mistakes happens along the way. This is one part. Another part, I work also on water desalination and predictive maintenance. So on creating a digital twin for pumps and for desalination products. That's mainly what I work on, Rami.
Yeah, and so one of the impressive things that you have not mentioned is that actually you have completely taught on your own an undergraduate course. So when I was at Langley myself, you took over the manufacturing course, and you have done quite an impressive job. So not only
a great experience for me, I think, teaching a class of 106 students for a first class of 106 students was a great experience for me. And I'm also really excited to teach this course again in summer, but it's going to be a totally different experience for me, especially that it's a smaller class and online. And I've tried a couple of sessions in your current class, so I'm trying to familiarize myself with the new concept, but I'm hoping that it's going to be a great experience.
I'm sure it will be. You're nothing short of having stellar performance in everything that you do, and of course, like this is impressive. Like what you've achieved from publication, from research, from teaching, but also you have another thing that you do very, very well, which is services. Recently, you've been playing a little bit a role of program manager as well. So I'm looking forward to see that grow more and more. So this is a picture of you where you're presenting at Aerodef. So Chris was saying a few seconds ago that he doesn't believe that Clint existed without a mustache. So
I'm convinced Clint was a 2-year-old baby with a full mustache.
Yeah, this is when I was a 2-year-old baby presenting in Long Beach, California, about my master's thesis, I think. And this guy, Rami, I think, can talk more about him.
Yeah, this is Lane Ballard, one of the high executives at Boeing, and we've had the opportunity to meet several times, and it was so kind of him to come visit and talk to you about your part criticality, which is part of what was part of your research during your master's, now that you're on your PhD. All right, this is awesome. Thank you so much, Clint. Is there anything else you want to say?
No, thank you for first having this course, and hopefully we'll see more courses in the future.
All right, awesome. Yeah, I'm gonna do it, but not daily. The daily was was a bit too much. All right, let's go ahead and see who do we have next. So next we have Drew Sander. Drew is one of the undergraduate researchers that just joined the team, And what's special about Drew is Drew actually was visiting us as a high school program, like 3-4 years before he joined, and suddenly now he is part of the research team. So this is very, very good. We're very proud of Drew and everything that he's been doing so far. All right, let's move on to Mr. Halbritter. How are you doing, Josh?
Doing good. Thanks for having me on.
It's always a pleasure to have you. So, Josh, I did play a couple of days ago the full software of your CAPP software. I mean, this is something that we've been working on, and this is a little bit. It's progressing to become a full-fledged software now. And there's I know that Alex is working on this. I know that Chris is working on this. Like, we're trying to combine all of this. Tell us a little bit about the CAPP software and your research.
So currently the CAPP software, it began as almost as my undergraduate project. We began with building up the foundation through a series of surveys and investigations of kind of the process planning that's been performed for developing composites. So the primary stages of that are looking at the defects, fiber defects that occurred during layup, in addition to the actual process planning function. So what is somebody doing on the computer to actually program the robot to design the part that they're interested in making? So for example, on this one, you can see we have the a very complex saddle tool, and it's not a trivial task to develop a motion that will manufacture this part.
I can totally imagine the complexity that you have to deal with when we have those discussions and you're trying to analyze all the different elements of the CAPP software. I'm going to add the Clint to the stream again. At the start of this project, both of you did a tremendous effort in categorizing all AFP defects and like the AFP defects that. So tell us a little bit about that.
I think we also need to give a shout out to Stephen Williams, one of our previous undergraduate students who played an important role in helping us categorizing the process control, the process part. And yeah, this started when I came here like 4 years ago. And what Rami asked me is go figure out the defects and how process design works on the AFP machine. And this is how it started. And look where Josh is now with his software. Josh, if you want to pick up and tell more about your experience.
So I actually yesterday got a notification that this paper, the AFP defects paper, actually jumped above 10 citations. So within a year, it jumped above 10 citations, which means this is poised to be a good reference material for future work. All right, Josh. So besides your research, so now we're starting a PhD together and looking forward. We actually did it right in some sense that you're done with your courses, and it's nothing but joy all the way down the road and research.
I'm glad we've been doing things very efficiently, and we're getting really good results out of it.
And what's something special about Josh, and I'm glad I just remembered to say it now, is Josh was in my statics class like perhaps 6 or 7 years ago.
It's forever ago.
It's forever ago. You know, it's your choice to stay with me or not. All right. So, Josh, tell us a little bit about this visit. Where did we go here? What did we see that day?
Yeah, so this is a really fun visit that we got to do down to Boeing. I believe you did it as your one of your classes, and as part of the Sampi Club as well. Yep,
and I can see you here. And actually, I can see here on the left Dr. Bayoumi, who's the director of the McNair Center, and several of the team. Like I see Mazen in here. I see Tyler Dillard. Shout out to him. I see Wout. I think this is Vijay Soni, and he works right now at Boeing. So Shout out to VJ. Okay, there is so many folks. I'm not gonna be able to name. Is that Rudy next to him with glasses? Yeah, that's Rudy. Where is Rudy? Hey, Rudy, how are you doing?
Hello, Rami. I'm doing good.
Yeah, so this is a good experience. You were one of the SAMPI graduate advisors.
Yep, I started SAMPE back in 2017 as vice president and the student chapter at USC, and was the graduate advisor. And we participated in several tours for companies and industry, as well as the bridge competition at the SAMPE conference almost every year.
You won a SAMPI award in 2018, or
Yeah, the University Leadership Award. It was part of my role as the vice president and founder of the club at USC.
all right, this is awesome. All right, let's see who we have next. So Kaishu, let's call on Kaishu. Thank you so much, Josh. How are you doing, Kaishu? You are you're muted yourself. You have to unmute yourself.
Oh, sorry about that.
How are you doing, Kaishu?
I'm doing good. How about you?
I'm doing good. This is it's crazy times, but we are powering through all together. I mean, as I keep saying it, I have the best team in the world. So tell us a little bit about your research, what you do, and talk to us a little bit more.
Hi everyone. My name is Kai Shu, and I have been working with Dr. Herrick with Future Fact for 2 years, and my research topic is mostly first in the robot PLC control systems and for manufacturing processes. And besides that, I'm also investigating in how to utilize a digital twin technologies for smart manufacturing systems. For example, some of the emerging technologies such as virtual commissioning, IoT implementation, and machine learning approaches. So my ultimate goal for my research is that I can at least implement a decision-making system on an autonomous manufacturing process based on the data retrieved from the digital twin. That means both of the data from the process and the product, so that I can make like the prompt decision based on the feedback from the cell.
This is awesome, and we have a couple of pictures that we're going to show in a little bit of time for the Future Factories platform. This is like the team is working on creating a new standard when it comes to how future factories look like.
Yes,
so you're a friend to a cat and a dog.
Yes.
This is you have both Tom and Jerry in the house.
They don't live together, but I leave them in 2 different places. I have been spending a lot of quality time with them.
That's awesome.
Yeah.
I've been also spending a lot of quality time with my cat. Alex can.
It's now a hairless cat.
All right, so Kaisha, tell us a little bit about this trip. What happened in here?
So this is in 2019 when we are presenting our work. So me, Chris, and Clint, particularly, we are presenting our work on our stage 1 platform on Future Factory. So with all of our other colleagues in SAMPE 19, yes.
All right, this is awesome. I tried to remove myself so that I can highlight all of you at the same time. This is I want to make a shout to Anis. Anis Bazradwan. He was a master's student in our team, and he's now working with Desktop Metals. And a big shout out to him. He's a great team player. So this is some of our team, but also we have friends from the Office of Economic Engagement and other people that were participating in the SAMPE conference. I can recognize This is James and Soma. They've been working very, very hard in this COVID-19, trying to 3D print face shields and so on. So a big shout out to them. All right, so next I have Kevin Zimovan. Kevin is one of our undergraduate researcher. He just got a Magellan Scholarship, so this is something we are super proud of. Actually, in my team, undergraduate students are encouraged to seek funding, and this has been working so well because almost everyone had acquired some way or some other way funding through Magellan Scholarship, a C Space Grant, McNair Junior Fellowship, and so on. So this is a success story. Kevin is interested in space, and he's working on trying to understand gravitational effect on 3D printing and so on. This is Max. Max is one of the affiliated folks in our team. He is a Siemens employee. We did research as undergraduate long ago. Now he works at Siemens, but he is a next graduate researcher. He's working on like the digital twin of the AFP, of the future factory, and relevant to dynamic path programming. Noah has gotten a Magellan Scholarship almost a year ago, and he has been working on so many different topics. Mostly, he's focused on the work with Joshua. So he works with Joshua a lot on the CAPP software, which soon we're gonna stop calling it CAPP, and we're gonna come up with a name. We're thinking of neXt, but Alex has not approved the name yet. Did you approve the name, Alex? neXt?
I think we have so far.
All right, cool. So
I think it's more up to Josh than me. He's the key player here.
I get to type it in the design.
so this is we're trying to consolidate. So Chris worked on a so let me go ahead and add the folks. So Chris worked on an inspection software. Rudy has done we're going to talk about it in a few seconds. Topaz modeling. Clint. So everyone has worked on islands, and we're going to try to consolidate all of these different elements within the same platform. All right. So with that, this brings me up to the discussion on Rudy's work, and so actually Rudy is no longer a student. He's a now doctor. I should not even say. I'm not allowed to say Rudy. I should say Dr. Wehbe. Rudy, tell us a little bit about your research.
So my research in the past few years, I've been working on modeling defects, and especially wrinkling and other type of toe deformation and automated fiber placement. Basically, the question I was trying to answer is what would happen to a toe when placed on a curved path? And curved paths are necessary to manufacture the complex structures for aerospace applications, also for doing advanced designs such as steered design. So the problem is when you have a straight toe that's in the tape form and you want to place it on a curved surface, there's a mismatch in length between the path and the actual material you're feeding in. So there are several possibilities of deformation that would happen, and some of them are problematic in the manufacturing. So the whole research was about trying to figure out what caused these defects, how would they appear, how could we alleviate that, what kind of properties would affect it, and we tackled the problem from three different perspectives: geometry, mechanics or material properties, and process parameters. And we recently have a paper published on the geometrical aspects of the defect prediction. It got published like 2 days ago.
I wanted to congratulate you on that. I mean, this is nothing short of impressive. Your work has been recognized in Composite Structures, which is one of the most premium journals, and it talks a lot about the quality. You're very persistent. You go after something, and you keep drilling until you uncover it. And this is nothing short of impressive, Dr. Wehbe.
Thank you, Rami.
So this is good, and I also have to share that you have also taught courses. So you've taught the computer-aided design course. You have substituted for so many courses, statics, and so on. And I think, like in my humble opinion, you are one of the few people in the world that would be perfect for teaching a composites course because you understand composites design, you understand composites manufacturing, you understand the whole chain, and that poses you as someone who can tell the complete story for students. So think of it, consider that like whatever
Thank
you.
you, Rami.
All right, awesome. So what did we do here? Where were we?
So this was in Gulfstream, Savannah, in Georgia. It was a field trip with the SAMP student chapter, and we saw all the private jet in the making, and we had like a close-up tour of the facility in Savannah, Georgia, of the Gulfstreams.
This is awesome. And I see so many, like I see Ronak, he helped me set up the SAMPI chapter. So when I wanted to get the SAMPI chapter to USC and I spread it out, I didn't know him. He came forward and he helped me out. I see so many folks, Adam, Elvis, Jan. I see in here Sahil and Ludus. They were part of the first undergraduate students that joined us. I see also Luis, who has graduated. So many folks, Stefan, like I see a lot of people that we dearly like. So this is awesome. Thank you, Rudy, for taking us back to this nice memory.
Thank you, Rami, for having us here today.
Yeah, this is fun. All right, awesome. So we have Sagar. Sagar is one of the sophomores that just joined the team almost a year ago. He is a go-getter. He's the vice president of SAMPI, the outreach chair for ASME. He does the annual Tiger Burn. I'm still very confused about this Tiger Burn activity, but this is I see Kaisho also laughing about this right now. So I have to.
We pretty much burn a Clemson Tiger every year around the rivalry game.
Rivalry season.
I still don't wrap my head around that activity, and everybody is excited. We want to burn a tiger that represents Clemson. I mean, this is. But hey, I get it. So, but how? You know what? I've always wondered how do they? We should one day include composites. Like perhaps we manufacture like a composite rocket for that tiger burning.
We considered including Sampy and making a composite rocket to shoot at it and light it on fire.
Yeah, that's I don't know if that's a good thing, but I like the idea. All right, awesome. So saving the best for last. I mean, everyone is very dear to my heart, but especially when it comes to this composites course, there is no way on earth that I could do 30 days without your help, Alex. Like there's no way, absolutely no way. And
it's been a lot of work. Yep, I couldn't imagine doing it just one person.
and you know, this is so let's do it this way. Why don't you start by presenting yourself and your research and what you're working on?
So I'm a master's student. Started about a year ago now in aerospace engineering. And my main focus is working with Max and Drew Anderson on developing an AFP twin. So you can see the model there on the right that give a big shout out to Max, because without Max, this wouldn't even be possible. And then, as we heard earlier, we're starting our neXt research, which stands for neXt Composites, where we're trying to include pretty much every aspect from the AFP process
So you
into a single software.
So you approved the name because you're now
We've been calling it so far.
All right, good. Josh has approved it as well.
Yeah.
All right, awesome. All right, go ahead, continue, Alex.
So we're basically trying to take everything from design to process planning to manufacturing, inspection, curing, and put all that data into one place. And then that way, over time, you kind of learn how to improve your overall design from each of those standpoints. And I also do some part-time research in the Future Factories platform. Recently, we just started some new drone inspection research that we hope to get up and running as soon as we can get back to the lab, that is. And then I'm also the team leader for the SAMPE I-beam bridge competition that they have yearly, except for this year, that we design and build a beam and go have it tested at the conference.
Yeah, right.
And down there on the bottom, that's me and Chris. We recently helped with some younger students, teaching them about composites for SAMPE.
And this is always amazing. We're doing tremendous efforts to transmit the word to high school students and to let people know about composites and coming up with new ways. I remember when you guys sent me the image, and I'm like, you really are not talking about the inverse rule of mixture with.
They were actually interested.
Yeah.
Somehow, I don't know how.
Hey, we had a bunch of 10-year-olds do one of the better Vardem setups I think I've ever seen. So
One of them did it absolutely perfect. It was.
I believe in this. I believe so. So okay, I'm gonna go ahead and talk about this. Sometimes people tell me, how do you trust having undergraduate students even in your research? So this is like what puzzles my mind, is that I trust like not only undergraduate students, high school students, sometimes they make the best work, and they are, if somebody is motivated and has passion with directives, they can come up with the best. So I believe what you're saying. All right, cool. So go ahead, continue, Alex.
And that's me in the bottom left there. When we visited Langley, that you saw the picture of earlier, we actually got to go see Isaac, their AFP machine, and get all decked out in the clean room outfit and all of that. So it was a lot of fun.
Yep, this is cool. So, and once again, Alex has been a keystone in making this month happen. Without Alex, there is no way that it wouldn't have the same quality and it would not have happened. So thank you a lot, Alex, for all the chats and all the discussions and
I think we've talked more in this month than we have in the past year.
I think
pretty much every day.
pretty every day, and at weird hours. I'm like, yeah, I saw your slide. That's what that like 2 a.m. in the morning, and
it's been a lot of fun.
This has been a lot of fun, and it's a great experience. Thank you so much, Alex.
Yep, thank you.
So I'm gonna go ahead and try to add everyone to the stream and even try to. So we still have a couple of pictures to go through. We have, this is our future factories setup. This is what we're coming up with. This is something that we're gonna have a full, hour, 2 hour live on this, and we're going to talk about these things. And this is what we're trying to do in here, is set up how a future factory would look like. And we were making great progress, and then we were forced out of the lab, but we will come back and, this is another picture.
It's good to mention that this room was empty like 2 months ago.
Yes. And this is how it looks like right now. This is, I got a notification that Noble has joined. I'm gonna add Noble to the stream. How do I do that? I cannot add more than 6 folks. So let me see. How are you doing, Noble?
I'm doing okay.
All right. Awesome to have you. Awesome to have you with us. Noble is one of the project manager at. Go ahead, introduce yourself, Noble.
Oh, so Noble Anumbe. Actually, I'm providing support to this research team. My background is mechanical engineering. I finished my doctorate with the mechanical engineering department, and I've been working with the Office of Economic Engagement for I think 7 years now. So a lot of work in IP, intellectual property, corporate engagement. I help with a number of companies, IBM, Yaskawa, Siemens, and all of that, and help to provide support with the kind of work Dr. Rami is doing. And Dr. Rami is being an excellent professor. And I mean, the 30-day work is done here shows how far, the kind of work is done, and happens to help churn out some of the best, really best students within USC.
Thank you so much, Noble.
It's a pleasure working with you.
And it's a pleasure to work with
Right.
you. And even like all the interactions we have are, they are impressive, and it's always fun. It's always super fun.
Mm-hmm.
All right, so let's go ahead and light up the screen again. Here we go. So this is the future factories. Well, actually, I think this is our last chart. So before I wrap it up, let me put this screen. Thank you so much for all of you for the daily interactions and the fun, and making sure we have a great team, good mood, and we do have a lot of common points outside of research, and we do have rivalry over who makes the best kafta and who makes the best dishes. Of course, it's me, but like I accept that, like just to encourage you guys that
we'll have to do a blind test sometime and see.
Hey, I like that. I like that.
We can do that at the party after all this is over.
I'm game for that. We're gonna do that one day. Of course, I'm gonna win, but I'm game to, just to give you the opportunity. Alex, thank you so much once again. Joshua,
thank you.
Thank you. Rudy, thank you.
Thank you, Rami, for having us.
This is awesome. Noble, thank you.
Thank you.
And Chris, thank you so much. As well as Kaishu, Rudy, I don't know if I missed anyone. Thank you all so much. I'm going to wrap it up now. So to wrap it up, I wanted to talk a little bit about this picture. This is myself doing some work on AFP inspection. This is the most fascinating field that anyone can work with. If anything, these last 30 days, I wanted to transmit as a message for this Composites A to Z 30 days live special, is that composites are fun. Composites are actually not that complex. You have to take into consideration a lot of engineering elements, from design to manufacturing. You have to really understand the manufacturing to do appropriate design. But basically, these 30 days would put a cap, and this is a little bit a special with my research team. But composites are fun. I'm ready to help you whenever you want. Just communicate with us, open a chat. And when all of this blows over, you are more than welcome to come and visit us at the at our team in the University of South Carolina. So thank you so much for tuning in. This was the end of the 30 days, and looking forward to seeing you in the new version of the show. So I actually have to, where is Alex? I need to add Alex. So let me add some of you guys again, even though we said bye. So I'm gonna name the weekly show something, neXt something. So you have to come up with a name, neXt weekly or something, whatever. Do you approve that name?
I guess so.
I guess so. All right, awesome. Thank you so much. Thank you so much, everyone, and see you in a couple of weeks when we restart this, but on a weekly basis.